All right, so this is going to be very similar to what we did before, except they are basically doing one-sided limits, hence the title. But they will also talk about continuity. So I'll probably have to pull up those definitions for you. Let me grab those right now, actually, before I forget. One moment. Here we go. So let me give you the definition first before we start the problems. Continuity and one-sided limits. Let me get this in the right spot here. All right. So this is the definition of continuity at a point. So a function f, oops, it's not an f, f is continuous at C. When the following conditions are met. F of C is defined, meaning if you plug in C, it's you get an output. Number two, the limit of f of x as x approaches C exists. And remember what we said, what that means, right? We said the limit from the left and right have to be the same. If it is the same, then it exists. So add that extra note just in case you forgot. So if the limit of f of x is equal to, so from the right is equal to the limit of f of x from, I'm sorry, from the left is equal to the right, then the limit of f of x as x approaches C exists. That's what we mean by number two. Number three, the limit of f of x as x approaches C is equal to the functional value. So if any of these fail, then it is not continuous. All conditions must be met. Does that make sense? Okay.
I'm sorry, what does the third one mean?
The third one basically is saying that whatever you find for your limit is equal to you plugging in C. So I plug in C into the function, I get some output. that has to be the same as the limit as x approaches c. Yeah, let me show you an example, just in case that doesn't make sense. Okay. So the c in question, right, for number 1 in your homework, 2.4, c is equal to 6, right? What is f of 6?
3.
Yeah, 3.
Yeah, so it's going to be 3. You can see the point right there, right? Now, excuse me. As we approach from the right side, the positive side, what number am I approaching on the y values?
3.
As I approach, as x approaches 6, the y's are going to 3 from the right-hand side, the plus side. Hence, the answer is 3. From the left side, right, as I approach 6 from the left, what is the y value doing? It's going to 3. So since the limit from the right is the same as the limit from the left, then the limit exists. This is the just general limit, right? Now, does this question obey all those 3 conditions?
Yeah.
Yes.
This is defined, right? Limit exists, and the limit is equal to the point, right? So that's what it means to be continuous. So you would say, yeah, it's continuous at the point x equal to 6. You guys, is there any questions on what it means to be continuous at a point or how you check? Yeah, let me know. You guys, we're gonna do a couple. All right, let's move on then. Over here, what is, well, hold on. First of all, c is -2, right? There it is, yeah. So what is the function at -2?
2.
Right, f, what is f of -2? Right, it's not, this has a hole, so it's not that one. It actually is defined over here, right? What is the limit as we approach -2 from the right and the left? What are the y values doing?
Heading towards 2.
Yeah, they're both going to 2. So since both of them are 2, then the limit exists. But it is not equal to the functional value. Right? That fails on, that's what number 3 was saying. Condition 3 says that if you plug it in and get some number, that has to be the same as the limit as you approach that number. And here we have 2 and 3, right? So number 3 fails. So you would say, no, it's not continuous. On the exam, you would just explain yourself. Like, okay, why is it not continuous? It's not a yes or no question, right? You need to make sure you explain what's going on. Because the work itself is almost non-existent for some of these. I just need you to tell me Why? Any questions on 2? Like the answers don't matter. Just how do you get there? And what does it mean? Okay. Now let's move on to something else. Number 4. Let's see here. We have a few techniques now, right? On how to do this. On this one, I would probably graph it because I don't think I can do any algebra to help me out. Can you guys see the grapher?
Now I just see the journal.
Oh, it's not sharing anymore. Oops. All right, so we're gonna plug this into Desmos to see what it looks like. X over X squared. Is it minus 9? I don't remember. Yeah. All right. So the question is saying, what is a function doing as we approach -3 from the negative side? Okay, well, we can use another method. The first method we learned was just plug in numbers closer and closer on your calculator to -3. So like -2.999, etc., and see what it's doing. But graphically, it's the easiest method. You can see as we get closer and closer to -3, right? It kind of shoots off to infinity here. Yeah, I can't even click it for some reason. All right. But anyway, uh, you could say it goes to -infinity as we approach -3 from the left side. So I'm sorry, I should have said -3.0001 or something to see what's going on with the other method. But in this section, we're not talking about infinite limits. So we'll just say does not exist. So both answers are acceptable, but in the homework, they want D and E because it shoots off into -infinity. So does that make sense? Is there any, is that weird?
That makes sense. We just have to read the signs basically, see if it's going left or right, or if they exist or not. So that makes sense.
All right, thanks. So yeah, pretty much just if you see it shooting off to either infinity, in this homework, just say D and E. Just make sure you know what direction they're saying, where the values are. And you can use whatever method you want because it doesn't specify. So you can do graphically, um, analytically. If you see some algebra techniques, go for it. All right. This one, let's do this guy, I think. Excuse me. Yeah, let's go ahead and do 6. Okay, so for this question, you should see them plugging in -1 at the bottom will cause division by 0. So it's technically discontinuous at the bottom because you can't plug it in. So it violates rule 3. So you should be able to answer the first part, no problem. But because you can factor the top with the difference of squares, and then later you are able to plug it in, we consider that to be a removable discontinuity. They didn't ask for it in this question, but technically you can rewrite the problem and plug it in. So when that happens, you consider that removable. I think there's another one that they do ask it. Let me find one. Here. See how this was going to cancel the bottom? So the one that is removable is a factor that cancels. The one that doesn't cancel would be non-removable. Let me write it out real quick so you can see what I'm saying in case your algebra is rusty. Let's see how you have 2 points of discontinuity because you'll have division by 0. But one of them cancels, so we consider that one to be removable. But since this one's not going anywhere, right? This is non x equal to -3 is non-removable. X equal to 3 is removable because it canceled. Because originally I had issues with -3 and 3, right? But I no longer have issues with this one because it canceled. So that's the easiest way to tell if something is removable is check if it cancels. That's why they answered this way. Does that make sense? All right. That's pretty much it for 2-4. Now I'm going to move on unless you have any questions about continuity or discontinuity or why it's removable and when is it or why not. Let me know.
So the non-removable one is the one that you canceled out.
The one that cancels is the one that is removable. Right, because I can now you are the one you are now able to plug it in kind of, right? Because 3 does not make this 0 anymore. Because the one that made it 0 is gone. Does that make sense or
Yeah, that makes sense. Thank you.
okay? But if you guys have no further questions, we're moving to 2-5 then. So let me know. Here they actually want you to put infinity instead of does not exist. Okay. So look at this carefully. as we approach 2 from the left, the negative side, so here's 2. As we approach it from the left side, you can see it's shooting off, right? And as we approach from the right, same type of deal, no? So since they go to infinity, then you would just put infinity. Is that clear? It's not nothing crazy, right?
No, sir.
The same deal here. As you approach -2, which is right there, from the left side, shooting down real quick. So that's going to be negative infinity. And from the right side, I'm shooting up pretty quick. So that's infinity. So since the limits are going to 2 different infinities, you'd say that the actual limit does not exist. If they're going to the same infinity, you could say the normal limit is infinity. There any questions on number 2? There's not really much to do by hand. I just need you to be able to explain that, like plain English if you want. Is that clear?
Yeah.
All right. So if they don't give you a graph, you're gonna have to graph it yourself. Or plug in numbers closer and closer from the left and right hand side, depending on the scenario, right? If you got no calculator or no graphing calculator, you can just plug in numbers really close and see if they get big really quick. Then that's an indicator it's going to some sort of infinity. Especially if it's like humongous, closer I get. Well, let's see what's going on. X -2. So as we approach on the left-hand side, negative side, shoots downward, so negative infinity. From the right, positive infinity. So left, negative, right, positive. No big deal, right? Over here, they're doing what I mentioned. As you plug in closer and closer to -2, which is the value causing division by 0, you can see how it gets big really quick. That's an indicator that it's going to infinity, positive infinity. But on the right-hand side is getting big but negative, so negative infinity. If you're using this method, that's what you're gonna have to interpret. Let's see here. Do you guys remember your asymptotes, like how to find them back in college algebra? Do you remember when they happen?
To be honest, it rings a bell, but not really.
So, it's in a nutshell. We don't have to get super deep into it, but anything that may cause a division by 0 is a asymptote. So -2, right? If you were to factor this, you'd have 1 over x plus 2 times x minus 2, right? Difference of squares. So we can see that -2 and 2 causes division by 0. So x equal to 2, x equal to -2 is going to be my asymptotes, right? So x equal to -2. Let's see if we can get a better graph. Here. You see what I'm saying? You have an asymptote at -2 and 2 because those 2 points create division by 0. So the asymptote equations would be these two. And that's all it is. And the definition of the idea of asymptote was basically a value that the graph approaches but never touches. It gets infinitely close but never crosses it.
Okay, thank you.
So right here, they're going to ask you, okay, well, find the vertical asymptote. So you have to find out, okay, well, is there a value that makes the bottom 0? Can this bottom ever be 0?
No.
No, right? There's nothing you can square.
That'll equal -9.
Yeah, there's no way you can make it -9, correct?
Yeah.
Because if you and everything you square becomes positive, so it'll never cancel this 9. If you try to solve this, if you set t squared plus 9 equal to 0, right away you're going to see, right? It's a horrible writing here, but if you try to solve this, t squared plus 9 equal to 0, there's no real solution, hence does not exist. So there are no vertical asymptotes for this guy. You can also graph it and just see, like, okay, well, does this type of scenario happen? Do you see 2 and -2, or I'm sorry, do you see two areas where the graph is kind of approaching but can't cross? Right here, you can see super easy in number 10. You see how 2 would make this bottom part 0 if I plug in 2. So all you would say, well, the equation x equal to 2 would create a vertical asymptote, a vertical line. Number 9 is the only one that's a little different because we should all remember you cannot have 0 inside of a logarithm. No log can have a 0 as a result inside. Right? All the domains for logs are greater than or greater than 0, not equal to. So x equal to -3 would be an issue. which would be a vertical asymptote. But for the most part, just check. Is what's going to make the denominator 0? What's the equation of the asymptote? And if something cancels, that's a removable. That's what we talked about before. Is there any questions on that idea? I mean, there's not, I don't want to beat the horse to death, but does it make sense? Or is there any confusion?
It makes sense.
Just let me know if something, if you missed something or fell asleep, just tell me. It's not a big deal. I know it's late. All right. Let's see where we are on the syllabus. So we just did 2-4 and 2-5, so we're a little bit ahead, kind of. So maybe we can take it easy next week. Next week we'll do test review, maybe answer some homework problems, stuff like that. We'll figure it out. Test 1 needs to be done by the 12th. So at this point, I'll be trying to get the homework done, get everything out of my way, and then start reviewing. But we still got a lot of time. About 3 weeks, a little less than 3 weeks. Yeah. Well, 2.5 weeks. So it's very early, just giving you a heads up. Do you guys have any homework questions you're struggling with or any concerns? I think we're going to stop lecture here. Any problems you want to work on or?
You said before we do the test, we'll review.
Yeah, I'm going to try to do a review before that, probably next week. So we'll do it early. That way you can go over it.
Oh, okay, okay. Thank you.
All right. If you guys have no questions, you're welcome to head out. And if you do, I'll stick around for a while.
Are you gonna take row?